Hi guys, welcome to Topaz tutorial. We're going to be looking at reaction kinetics. Actually, I'm not the one taking you chemistry. Your tutor would. We have a lot of tutors that will come and take you, and we have them. We have many people that will be coming on our YouTube channel to take you different courses. So basically, I'll be taking you physics, and also some other tutors will be taking physics. I'm not the only one. Now, we are looking at graphical representation of instantaneous rate. One of our tutor, one of our good tutor in Chemistry 156, Medication, is going to be taking you reaction kinetics and almost all the topic in Chemistry 156. Okay, but then I just want to do these aspects with you. What do we mean by when you say graphical representation of instantaneous rate? What do we mean by instantaneous rate? So before you can understand instantaneous rate, you have to talk about what is rate itself. Rate means per unit time. Okay. So when you say rate of reaction, that means I'm talking about the reaction per unit time. Now, what is reaction? Reaction means reactants reacting together to give you what? Product. So when you say rate of reaction now, you say rate of reaction is reaction per unit time. Okay. Now you can say it's rate of A divided by time, rate of B divided by time, and rate of C divided by time. So because this is rate of, or you can say rate of reactant divided by time and rate of what? Product divided by what? Time. But in another way, the reactance is reducing, okay? And we use a technical word. We talk about it as disappearing. It's reducing, but technical word is disappearing. While the product is increasing, the technical word is what? Appearing. So you can say that rate of reaction is the rate at which reactant is disappearing with respect to time. Or you can say it's also rate at which the product is appearing with respect to what? Time. Now we have two types of rates. We have average rates and we have what? Instantaneous rates. So if they will ask you that what is average rate of A now, it will be the average rate of A is what? Change the concentration of A. Now, please, when you talk about rate, we are talking about concentration. Concentration is the one that is reducing and increasing. Okay, when I say A, when that A is disappearing, I mean concentration of A. Okay, so concentration of A, concentration of B, concentration of C. Now these brackets signify concentration. Square brackets signify what? Concentration. You have to know that. So now concentration of C with what? Divided by 8. Now this is the average rate. This is the average rate. So what do we mean by this? We are looking at in an extended time. Okay, we are looking at the whole reaction. So we can also say average. That is average rate of C. Okay, we can also say now is now what you want to look at it. That's question of C final minus what? Question of C initial over what? Time. That means you can also say when C is 0 and when C is what? Final. In this case now, before the reaction takes place, C is 0. Okay, so the initial of course there will be 0. Okay, based on the experiment being done. So what we are saying is that average rate, we look at it in an extended time. Okay, now the second aspect of rate is instantaneous rate. When you say instantaneous rate, we mean in an instant at a particular time. Okay, so as we wrote here now, if you look at A now, the average rate of A here is what? A final minus what? A initial. Quantity of A final minus quantity of A initial divided by what? Time. Do you understand? Now, to now get the instantaneous rate, you have to limit this to 0 because what we are talking about, I want you to look at something. We are talking about an instant in time. So we have to limit the average rate to close to 0, not 0. Close to, I mean, getting closer to 0. Because we want to look at it tiny particular time, a tiny time. So what do? We limit this to 0, and what we do, we get, if we want to limit the A to 0 now, what do we get here? Limiting this one to 0. We have dA over what? Over dt. So that's what we did here. Now, that's how we get average rate and instantaneous rate. So how do we get average rate of reaction? Now I know now we talk of average rate. So average rate, when we talk about it, we can say is the rate at which A is disappearing. The one we did there now, we have not talked about the rate at which A is disappearing. I'm not going to go into that because we still have a lot to do today. Now, average rate. What's the average rate of reaction? for something to be rate of reaction, for it to be equal to each other, okay, the rate of appearance of A must be equal to rate of disappearance of A must be equal to rate of disappearance of B must be equal to rate of appearance of C. It's very important. For rate of reaction to be equal to each other, the rate of disappearance of A must be equal to the rate of disappearance of B must be equal to the rate of appearance of C. Okay, now remember we said average rate of reaction is what? dA over dt. Okay, can just say average rate of A is what? dA over dt. Fine. But we want to just make A to be equal to B. Let's add this formula. A plus B will give us C. Now in this case, A plus B will give us C. The average rate of A is equal to what? The average rate of B is equal to what? The average rate of C. That means the rate of disappearance of A is equal to the rate of disappearance of B equals to the rate of appearance of C. Why? Because there is no stoichiometric coefficient. There is no stoichiometric coefficient. So in this case now, we can say the average rate of the rate of disappearance of A is equal to what? Average rate of disappearance of B is equal to what? Average rate of appearance of what? C. So in this case, now look at this equation now. Because this thing is disappearing, you have to add negative value. You have to add what? Negative value. It's disappearing. Now, because the product is appearing, you have to add what? Positive value. It's very, very important. Because the reactant is appearing, you have to have negative value. You have to add negative value. But because the product is appearing, you have to have positive value. That's the first thing. Now, the second rule is that since the stoichiometry coefficient is not the same, you just have to divide it so that you can make it rate of reaction of average rate of A equals what? Average rate of B equals what? Average rate of what? C. Or you can say rate of disappearance of A equals rate of disappearance of B or equals what? Rate of appearance of what? C. For it to be equal, you have to divide this one by 2, divide this one by 3, divide this one by 5. So in this case, why our average rate of reaction is minus 1 over 2 is because now minus shows that it is disappearing. Like this one is reducing and this one is increasing. Minus shows it's disappearing. For us to make it equal to each other, we have to divide it by the stoichiometric coefficient to make this one A, B, C. Divide this one by 2, divide this one by 3, divide this one by 5. That's why we divided. That's why this one is 1 over 2, this one is 1 over 3, and this one is 1 over 5. Now the negative value shows that this one is disappearing. Negative value shows that this one is also disappearing. Positive value shows that this one is what? Appearing. I don't know if I make sense. Now, for the instantaneous rate, it's still the same thing, but the only difference is that we have limited it to 0. So we have the A instead of delta now, we have the A. So this delta shows average. This D shows what? Instantaneous. That does the difference. So this is how this is the overview. Okay. I'm trying to be fast so that we can get to what we want to do. Medicator will still explain all this to you. So let's quickly get to what we want to do today, which is graphical representation of what? Of instantaneous rate. It's very important we get to this. So we still have our we still have our 2A plus 3B will give you what? 5C. Now, to get the graphical representation, you have something like this. Now, why do we have something like this? Let's take this for A over what? Time. Time. Now, when we have something like this, you could have something like this, of course. Something like this, which is A. But in this case, it has to be log. Okay, maybe log A over what? The percentage of A over what time? Or ln. My colleagues will take you this, so I don't need to do that now. So what I'm saying is now this is the graph. It's a negative slope because A is disappearing. Okay, if you want to draw for B2, we draw the same thing for B. So it's also still be the same thing because it's what? Disappearing. Now if you want to draw for C, let me draw it. Let me come here for C. Okay, so that I want you to see something. This C over, you can call it the T. So for C, it has to go like this because it is a positive slope. Now, two takeaway here. One, it has to be curved, it cannot be straight. Second thing is that for reactant, it has to be what? Negative slope. Now for products, it has to also be curved, it cannot be straight, but it has to be what? Positive what? Slope. Okay. So now, how do you get the rate of appearance of C and the rate of disappearance of A? Now, to get the rate of disappearance of A, let's make it R of D of A. So the rate of disappearance of A now is equals to what? K equals to over A over what? Dt. Let's make this one dt. So now this is the rate of disappearance of A. Now what is the rate of appearance ROA of C is equals to what? C over what? Dt. Okay, so we can see. Now in this case, don't need to add negative because we have negative slope already. So now this is rate of disappearance of A. So we can see rate of disappearance of A. If you want to draw it, you draw a tangent. You draw a tangent. Okay? My marker is gone. You draw a tangent because we are picking a point here. We are picking a point in this place. So we are picking a point here. So you draw a tangent. Okay? Pick a point, draw a tangent to the x-axis. In this case too, for you to get the slope, you draw a tangent. Now I will come back to this. Now, assume you are given theta. Now, this theta here. Let me do the reactants first. I'll come back to the product. As we are giving theta here now, okay? Now, what is the rate of disappearance? I said it's also the slope. The slope is what? The angle is tan of what? Tan theta. So, this rate of disappearance of A now, or you can say rate of disappearance of A that they give you, because this is d over dt, is what? The slope. And then it's called what? Tan what? Theta. Okay, so that is the rate of what? Disappearance. But now the issue now is, look at it. I want to look at it well. Okay, I want to look at it very, very well. Let me come down here and draw that of C. Maybe you can see it. But let me just come here so that. Sorry. Let me draw that of C like this. Now, the tangent, let me use C, with C over T. Now, the tangent here, let's say this is the tangent, you draw something like this. Sorry. Don't mind me, I'm very terrible at drawing. So, now, this is your theta here. I want you to see the difference. That's why I'm drawing this in the both graph. This is A, this is C. Now, the angle here is theta. Here to the rate of appearance of C is also what? It's also what? The C over what? The T. Which also equals what? The slope, which is equals to also what? Tan theta. Hope you can see it. So now the rate of disappearance of A is what? The slope here is equal to what? tan theta. In this place too, is also this the slope is equal to what? Tan theta. Now, what is the angle we are talking about? Now, the angle is not this angle. Please, you have to be careful. This one is wrong. It's not this angle. The angle we are talking about is the angle that the tangent make with the positive x-axis. You remember that when we are doing physics, we have something like this. When we want to say the positive x-axis, we have to go from here to here. We move anti-clockwise. Remember, it's very important. Anti-clockwise direction. This is 90. This is 180. This is 270. We move from here to here. We move like this. We don't move like this. So this is anti-clockwise. If you draw a clock, normally clock goes like this. The end of a clock goes like this. But if it goes like this, that's anti-clockwise. It's not going clockwise. It's going anti-clockwise. So the direction to the positive x-axis has to be anti-clockwise. So the angle we are talking about is not this angle. It's this angle here. This angle here. This angle. So this is the theta we are talking about, not this theta. So in this case now, if we are given a question, okay, now look at this theta here. The angle we are talking about is the angle. So now let me just show you something. The angle we are talking about here, if you want to look at the slope, okay, I say it's tan theta. Because this angle, this is on a straight line. So your slope for this reactant is has to be what? Tan 180 minus what? Theta. For the reactant. But for the product, the slope is equal to theta. For the reactant, the slope is tan 180 minus theta. For the product, the slope is what? Theta. So, assuming we are giving something like this, let me rub this off. I'll give you two scenarios. I don't know, I'm not really prepared for this stuff because the marker is not really working. So we just accept the class the way it is. Now, assuming we are given something like this, okay, and this one is 30 degrees. This is your dA, and this is your dt. Now I said, calculate the rate of appearance of A. The rate of appearance of A, you know that the rate of appearance, ROA, equals to what? Of course, K equals to of A over what? T. D over dt. Which is equals to what? The slope, which is equals to what? Tan theta. Remember, your theta is from the positive x-axis. So if you use tan 30, you are in trouble. You understand? You will not get the right answer. If you use tan 30, you will be getting tan 30 is 1 over root 3. Okay? So if you use tan 30, you get 1 over root 3, which is wrong. So the angle we are going to use is this angle here. Okay, which is what? This is what? 1 what? 50. Okay? So your slope, your rate of disappearance of A. So rate of disappearance of A now equals to what? Tan 150 degree, which is what? Minus 1 over what? Minus 1 over root 3. So in this case, minus 1 over root 3. I think we are given the same question for. I just want to take note of this now. The answer is minus 1 over root 3. Why is it minus? Of course, it is what? Disappearing. You have to know that. So rate of A is what? Disappearing. So that's why it's minus. Now, if we want to do for C, assuming we are given for C now, assuming we change this one to C, the rate of appearance of C is equals to what? Tan 30 degrees. But we are not surprising because when we are talking about C, this is not the graph that we have for C. Okay? This is not the graph we have for C. This is the graph we have for C. Okay? And this one is what? 30 degrees. So remember we said this is the graph. So R of A of C equals to what? If this is the if this is what they give you, it's what? Tan 30, which is what? 1 over what? Why am I drawing root as 5? 1 over root 2. So I want you to note the difference. The rate of disappearance of A, the graph is different. The graph is not to do it like this, okay? But assuming you are given a question like this, okay, and they give you here to be 60. So the angle we are talking about is the angle we make with positive x, and this angle, which is what? 120 degrees. So your rate of disappearance of A, will be what? Tan 120. Please, you have to know this. But for products, this is the angle, this is what you get. So it's for product, you don't need to minus this, because now the reason why minus is what? Angle on a straight line. Angle on a straight line is what? It should be what? Tan 180 minus what? Theta. So it's what? Tan 180 minus 30. That's what? Tan 150. Very important. So this is very, very important. So I'm going to give you a question like this. Now let's do a question. Let's do a question. Please note what we are calculating. We are not calculating rate of reaction, please. It's very important. We are calculating rate of appearance and rate of disappearance. Now, let me give you an hypothetical question. Let's say this 2H. Let me give you question 1. 2H2 plus O2 give you 2H2O. This is gas, and this is liquid. So now calculate the rate of reaction. That's your A. Your B, calculate rate of appearance of H2O. Okay, and your C, calculate rate of disappearance of O2. Okay, so in this case now, they give you a graph. Give a graph like this. Okay, they give a graph like this, and they make this 45 degrees, and I call this the H2 over the T. Now, how can we solve this question? Calculate the rate of reaction, calculate the rate of appearance of H2O, calculate the rate of disappearance of O2. Now, what can we calculate using this graph? We can only calculate the rate of disappearance of H2. So, now first, let me write the rate of reaction out first. Rate of reaction for this equation, remember, is what? This one is disappearing minus what? 1 over 2. Remember? Measure of H2 with respect to time. Plus what? Minus 1 over 1. Okay. Measure of O2 with respect to what? Time. Equals what? Plus 1 over 2. Measure of H2O with respect to what? With respect to time. So this is the rate of reaction. Okay, you know why we use minus, we know why we divide it by 2, 1, and 2. We divide it, okay. So now, this is the rate of reaction. But what we can calculate using this graph is what? Rate of disappearance of what? H2. Okay? So, all this is the rate of disappearance of what? H2. All this is the rate of disappearance of O2. All this is the rate of appearance of what? H2O. You have to know that. No, that's not it. I'm just joking with you. Now, it's not it. So, now, this is the rate of disappearance of what? H2O. This. Okay? Without the coefficient, please. It's very important. So this is the rate of disappearance of O2, and this is the rate of disappearance of what? Of H2. Have to know that. Now, these two, this one divide this that the fact that we are dividing to by the coefficient is making it equals to the rate of reaction. Do you understand? Now, in this case, you know that our dH2 over dt equals to what? The slope. This is equals to what? Tan. So now, okay, let me round this off. I believe you know it, that we can use this stuff to solve this good equation. So now, the tan that we'll get, okay, this is what? Tan, remember, this is what we make with positive x-axis. This positive x-axis. Now 45 is now be what? Tan 180 minus what? 45 degree. That's what? Tan 135 degree. Tan 135 is what? Minus 1. You know that. So tan 135 is minus 1. Okay? So the rate of disappearance of H2 equals to what? Rate of disappearance. We are not to calculate that, of course. Of H2 equals to what? Which is equals to what? Minus 1. So what we are told to calculate is rate of reaction. Rate of reaction. Now, what is the rate of reaction, guys? Now, we know this one is minus 1, okay? Rate of disappearance of H2 is what? Minus 1. So, what is the rate of reaction? Rate of reaction. We are coming back to this formula, okay? Because we are given H2, we have to use H2. Rate of reaction equals to what? Equals to minus 1 over 2 the H2 over what? dt. But the H over dt is minus 1. So, ROR equals to what? Minus 1 over 2 minus what? Minus 1. Because this one that we calculated then is what? Minus 1.